And we're going to discuss how we construct this probability distribution. How do we get this table? How do we get this graph? How do we know out of how many tries, how many days it's going to rain? What is our probability? If we're going to go on a vacation somewhere and you have a 40% chance of rain, what is the probability that if you go for 3 days, it'll rain for 3 days? Wouldn't you like to kind of figure that into your vacation plans? 40% chance of rain is a lot for 1 day, right? Imagine being there for 3 days and having 3 days of rain. So we'll forecast what will happen. We'll predict what will happen. Does it mean it necessarily will be that way? No, because it's a probability type thing. It's likely to happen. Does it mean it will exactly happen? The probabilities give you the likeliness of something happening. So that's something that we're going to talk about for this. In the beginning, it's a little bit dry. It's a little bit like definitions, but then we kind of get rolling into your probability distributions, and they get more fun. So we're going to talk about your random variable. Now, we use the x to represent 1 day of rain, for instance, 2 days of rain. Your x is your variable that we're going to be using through this whole thing. It represents a numerical value associated with each outcome of your probability experiment. How many days rain we want? We want 3 days rain. That's our x. We want 2 days rain. That's our x. It's just a variable that we use through the whole thing, so that when you see x used, you'll know where it comes from. Now, we have 2 types of variables, and this is really, really important. We have a discrete, and we have a continuous. Now, if you think about the word continuous, if you made a continuous line, you'd never pick up your finger, right? Right? So on my number line, if this is my number line, and I make a continuous line from here to here to here to here, this is continuous. It counts all of these little points in between. Continuous counts everything in between. I drink a glass of milk. I have 7.2 ounces of milk. I have 6.15 ounces of milk. It's continuous. It doesn't have to be the exact number. Discrete, on the other hand, is finite or countable. This is what we're going to remember discrete by. Discrete says this is 1, this is 2, this is 3, this is 4. It's a countable number. How many books you have on your desk? You have 3.5 books? You have 1, 2, 3, 4. How many people walk by our door? Discrete, countable. How many classes you have in a day? Discrete, countable. How many cars drive by our street? They're countable. They're discrete. If you have anything with a fraction, this is how you remember it. If it has a fraction or a decimal or any part of a number, it's continuous. If it's only a whole number, your integers, your countable numbers, 1, 2, 3, and up, then you're discrete. This is important that you remember this, because we kind of do 2 things. We do a discrete one and we do a continuous one. And just for a heads up here, discrete gives us a little bit of a problem. When we do that graph that you saw, sometimes what happens with the discrete is we don't get the little values in between. They kind of just jump over. Remember how we did your little boundaries on some of those graphs because they made a gap? This is going to make a little gap as well when you deal with discrete values. So we're going to have to do something to handle those little gaps in there.
Was that a Pareto graph that was like that? Was that a Pareto graph that was like that?
Well, yeah, that was one, just your histograms, your frequency histogram graph. Your Paretos, remember, go high to low. Yeah, but remember in the beginning, after we did it, we said, really, when you stop at 8 and then you go start at 8 again, you really don't. You start at 9 because you have a little gap.
Yeah.
And so we put those little boundaries in there. We took half and half and we met in the middle. It's kind of similar to this. We're going to have to do something similar later on in this, but not right now. Okay, so now, your discrete probability distributions have to have 2 conditions. 2 conditions. This is your probabilities. The probability of each discrete random variable, this is your x variable, has to fall between 0 and 1, which you know, right? Well, probabilities fall between 0 and 1. They can't be greater than 1. They can't be negative. And the sum of all possibilities have to equal 1. In other words, I roll a dice. Probability of a 1, 1/6. Probability of a 2, 1/6. Of a 3, and so on. All the way, I list all my possible outcomes. These are all possible outcomes. What do they have to add up to? 1. They have to add up to 1. And they have to be between 0 and 1. One of these can't be 7/6, right? They have to add up to 1, and they have to be between 0 and 1. You can make it a decimal. You can make it a fraction. And we're going to keep our decimals so that everybody stays on the same page for probabilities at 3 decimal places. 3 because, or if it's too many zeros in there, you want to make sure you have enough for a significant number on it. So these are the 2 conditions that must be met for us to know that we have a discrete probability distribution. We have to meet these 2 conditions. So we take a look at your examples. Example 1 says, decide whether the random variable x is discrete or continuous. X represents the number of stocks in a Dow Jones Industrial Average that have a share price increase on a given day. We want the number of stocks. Is that discrete or continuous? Discrete. This is what you're looking for. The number of stocks. This is discrete. How about the share price? What's that? Continuous. Okay, because it doesn't have to be $1. It can be $1.35. It could be $1.78. It could be any partial part of $1. But this guy asks for the number of stocks. So you have to listen to what it's asking for. Okay. X represents the volume of a bottle of water in a 32-ounce container. Would this be discrete or continuous? Continuous. Continuous. Okay, anything that has decimals, fractions, continuous. Anything that is counted by a whole number, measured by 1, 2, 3, whole numbers is discrete. The days left till Christmas. Is that discrete or continuous?
Discrete.
Discrete if we're counting our days, right?
Yeah.
It's discrete. How about the minutes left to Christmas? Continuous. Okay. Because we could have like a minute and a half. We can have a day and a half too, yes. But usually when we count our days to Christmas, you know, when you do your advent calendar or whatever, you count your days off, you mark off calendar. So we count them days. Okay, I want you to take a minute.
We should also put it in my house.
Darren, take a minute and answer these 2 questions. Come on, guys.
I already have the answer.
You already have the answer.
I already have both answers right next to you.
I went, no, Arian.
Okay, so can you, Joseph, answer?
Together in perfect harmony.
Sure, can we do that together?
Alright.
Okay, if X represents a length of time to complete a task, is that continuous or discrete?
Wait on. Discrete.
I thought, see,
Oh, wait.
Thank you, Anthony.
Continuous.
I should have not put the 2 groups together.
Never you messed me up. I didn't even read the question.
I just looked at you and I was like, dang, Joseph.
I trusted you. I thought you were a Pokemon master.
However, Joe, I thought you were doing it at the same time as him.
But see, if I said it wrong and Darian said it right, then I'm gonna look stupid. I'd rather go down with Darian than go shine.
You'd rather look stupid with Darian
Yeah.
than
Don't
without
let
him?
left behind. You look stupid, we all look stupid.
Okay, how about X represents the number of
Alright, we
home
got
runs?
this time, right?
No,
Oh,
no.
no.
We're letting somebody else go. Catherine, what would you say? Discrete. Thank you. These are accountable. These are accountable. Nobody ever hit a home run and a half, right? That's something you don't see too often. Okay.
Well, isn't half a home run a ground rule double?
Yeah, but that's a half a home run. Hallelujah.
Yeah, a home run in the
Yes. Okay. All right, so before we do this, since we seem to be struggling with today, guys, oh my goodness.
I